Welcome to the deep dive.
Great to be here.
Today we're really getting to the nuts and bolts of building something pretty cool. A web app for creating web scraping workflows visually.
Yeah, it's this idea of automating browser tasks, but instead of writing code line by line, you're dragging and dropping components.
Exactly, like building with digital Legos. The source material we're digging into calls this system ScrapeFlow, and it gives us a really detailed look under the hood.
It's a fantastic case study, actually. Shows how you stitch together different technologies, front-end, back-end, databases, to create a functional, complex system.
So let's start where the user starts, the visual editor. That's the heart of it, right?
Absolutely. It's the canvas where all the magic happens.
And the source points to using React.Flow for this, which makes sense. It's built for these kinds of node-based UIs.
Right. React.Flow gives you that foundation, rendering the nodes, the little boxes representing tasks, and the edges, the lines connecting them. It handles the visual logic.
It turns this abstract idea of a workflow into something you can actually see and manipulate.
Precisely. You see the steps, the nodes, and how data or control flows between them, the edges. It makes complex processes, well, understandable at a glance.
But you need the building blocks first. Where do those nodes come from?
Good question. They don't just appear. There's a task menu.
Like a sidebar, the source says.
Yeah, exactly. A panel listing all the available actions you can use, things grouped like user interactions or maybe data extraction.
And you literally just drag an action from that menu onto your canvas. Boom, new step in your workflow.
And each of those items in the menu, each task type, is carefully defined. It's not just a pretty icon and a name.
But the source mentions they have like a type identifier, a label.
An icon, yeah. But
Yeah.
crucially, defined inputs and outputs.
That's the key part, isn't it? What data it needs to run and what data it produces.
Totally. It dictates how these blocks can connect, like knowing which pegs fit into which holes.
The source gives some great examples of these tasks. Things like launch browser.
Which is often marked as an entry point task, meaning it can actually start a workflow. Makes sense.
Then you've got things like get HTML from page, extract text from element, click element. You can immediately see a scraping process forming.
You really can, step by step, and think about extract text from element. What does it need?
Well, the HTML, obviously.
Yeah.
And some way to find the element, a selector.
Exactly. A CSS selector or maybe XPath, those are the inputs. And
The text it's out, a string, presumably.
a string, yeah. The source is specific about these types. The system uses these types, string, browser instance, whatever, to validate connections.
So you can't accidentally connect, say, the browser itself into an input expecting just text.
Right. It prevents logical errors right there in the visual design phase. Smart.
We also see tasks for moving around. Navigate URL, scroll to element, standard browser stuff.
And then getting the results out, like deliver via webhook, send your data somewhere else. And another neat detail the source mentions, sometimes an input doesn't need a connection.
Oh, right. Like the starting URL for launch browser. You just type that in.
Exactly. And in those cases, the UI can actually hide the little connection dot, the handle, to keep things cleaner, less visual clutter.
Makes sense.
Yeah.
The source also mentions this idea of a credits cost associated with each task. We should probably circle back to that later.
Definitely hints at the business model. But yeah, let's stick with the building process for now.
Okay, so you've dragged your nose, connected them all up nicely, tweaked the settings. Now what? You got to save it.
Right. You hit save, and the system needs to capture that entire visual state.
The source mentions the editor library, React.Flow, usually has a function for this, like to object or something similar.
Yeah, something that exports the current state, all the nodes, their positions, their configurations, and the edges connecting them into a structured data format, usually JSON.
And that JSON blob is what gets saved.
That's where the backend and database step in. The source points to using Prisma here, a popular database toolkit,
So Prisma takes that JSON.
and stores it likely in a specific field within your workflow record in the database. The source calls this field definition. It's just a string containing that whole JSON structure.
Clever. So loading it back is just retrieving that string and feeding it back to React.Flow.
Pretty much. Rehydrating the visual editor from the saved state.
Now, if you're saving workflows, you need a way to see them all.
Naturally. So there's a workflow list view mentioned.
Probably using standard UI components like cards.
Yeah, seems likely. Each card showing key info, workflow name, maybe a status.
The source says draft or publish. Makes sense.
And that credits cost. Again, The total cost for the entire workflow, summed up.
So you know roughly what it'll cost to run before you even open it.
Exactly. And the source also mentions the UI within the editor, a top bar,
Standard stuff, right? Back button, title.
and the important buttons. Save, obviously, and execute. Right there, ready to go.
Okay, execute. This is where it gets really juicy. Building is one thing, running is another beast entirely.
Oh, absolutely. Click and execute kicks off a whole sequence of events behind the scenes. It's not trivial.
So what's the first step, according to the source?
Analysis. The system has to look at that save definition, the nodes and edges, and truly understand the dependencies.
Figure out what needs to run before what else can run.
Precisely. Which task's output is required as an input for another task down the line.
And this analysis results in an execution plan.
That's the term used, yeah. And interestingly, the plan is broken down into phases.
Phases? Why phases?
That's for optimization. If you have, say, 3 tasks that don't depend on each other at a certain point in the workflow.
They could potentially run at the same time, in parallel.
Exactly. Grouping them into a phase allows the execution engine to potentially run them concurrently if the infrastructure supports it. It can make the whole process much faster.
That's smart. Okay, so you have the plan broken into phases. What's next?
Setting up the execution environment.
Sounds technical. What is it?
Think of it like a temporary storage space or a scratch pad just for this specific run of the workflow.
Okay.
As each task in a phase completes, its outputs are stored in this environment. Then, when the next phase starts, tasks can pull the required inputs from this environment. It's how data passes between steps during the actual run.
Got it. It holds the state.
Holds the intermediate state, exactly. Then, the system actually executes the plan, phase by phase.
Runs the nodes in phase 1, waits, then phase 2, and so on.
And as it goes, it updates the status. The overall execution status and the status of each phase, pending, running, completed.
Or failed. What happens if something goes wrong?
Crucial point, the source is clear, error handling is built in. If a task within a phase fails,
The whole thing stops.
the whole execution stops, the overall status is set to failed. You don't want subsequent steps running with bad or missing data. It ensures a level of reliability.
Makes perfect sense. But if it fails, or even if it succeeds, you need to know what happened.
Logs. The source emphasizes storing logs for each phase execution.
Details like browser started or click the button.
Or error messages like, couldn't find element with selector X, or element has no text. Different levels too, info, error. It's your debugging trail.
So how do you see all this? The runs, the logs,
There's a dedicated runs list page for each workflow.
like a history table?
Exactly. Showing past executions, the unique run ID, its final status, completed, failed, the credits it used,
Duration, maybe?
duration, yep. All the key metrics for each run.
And the source mentions this table can even update automatically.
Yeah, using polling. Your browser just asks the server every few seconds any updates. So you can watch the status change in near real time if a workflow is running. Pretty neat.
Okay, so you see the list, but what about the details of one specific run?
You click on it. Clicking a run in the list takes you to the execution viewer.
And what's in there?
It shows the overall run status again, but then lists out each phase that was executed according to the plan.
Breaking it down.
And then you can click on a specific phase. That's where you get the really granular detail.
Like what?
Like how the nodes in that phase were configured for that specific run, what the actual input values were, what output values were generated.
Wow, okay.
And crucially, the detailed logs produced just by the tasks within that phase, it's full transparency.
That sounds incredibly useful for troubleshooting.
Absolutely essential, I'd say.
Now, clicking execute is fine, but true automation means...
Scheduling. Yep, the source covers that too. Using cron scheduling.
Cron, the classic scheduler.
There's a UI, like a dialog box, where you can set a cron expression for any workflow you've marked as published.
So you could say, run this every hour, or run this every morning at 3 a.m.
Exactly, and they even mention using a library like cronstru.
What does that do?
It translates the often cryptic cron syntax like 5 into plain English like every 5 minutes. Just a nice usability touch.
Definitely. Makes it much easier to confirm you set the right schedule.
So that handles the automated triggering, set it and forget it.
Okay, let's switch gears slightly. That credits cost we kept seeing. How does that play into the system? Monetization.
Looks like it. The source explicitly talks about a credit system for billing.
So each task costs a certain number of credits.
Right. And the workflow's total cost, shown on the card and elsewhere, is just the sum of the costs of all the tasks within it. Very transparent pricing.
And when a run finishes successfully.
The system calculates the actual credits consumed for that run and deducts it from the user's balance. Direct usage-based billing.
Makes sense for a service like this. Okay, one last crucial area, security. How do you stop people from, messing with workflows that aren't theirs?
Fundamental stuff. The source mentions checking the authenticated user in server actions.
So, whenever you try to do something sensitive, create, update, delete, execute.
The backend code verifies that the logged-in user actually owns the workflow they're trying to interact with. Standard practice, but essential.
And this applies to fetching data too.
Absolutely critical. The source stresses that database queries always filter by both the workflow ID or execution ID and the user ID.
So even if I somehow knew the ID of your workflow, I couldn't fetch its data because the query would also check if the user ID matched mine.
Exactly. It prevents unauthorized data access right at the database level. Super important.
The source even briefly mentions encryption.
Yeah, a quick note about possibly using symmetric encryption like AES with an initialization vector for sensitive data.
Like maybe stored input values or results.
Could be. It adds another layer scrambling the data so it's unreadable without the secret key. But, as the source hints, managing that key securely is paramount.
Right, makes sense. Okay, let's pull this all together. We started with this idea of visual web automation.
Yeah, dragging and dropping tasks.
We saw how React Flow helps build that UI, how the nodes and edges get saved as JSON in a database using something like Prisma.
Then how the system analyzes that definition to create an execution plan broken into phases for efficiency.
How it runs those phases in a special environment, tracking state and status.
Logging everything for visibility, providing views to see past runs and their details.
Adding automation with cron scheduling.
Implementing a credit system for billing.
And, crucially, securing the whole thing with user authentication checks and strict data filtering.
It's a really great illustration of modern application development, isn't it? You're weaving together so many different threads.
Totally. Front-end UI, back-end logic, database interactions, external libraries, architectural patterns like planning and execution environments.
Error handling, logging, security, it's all interconnected.
And that modular design, breaking the problem down into those individual reusable tasks, seems absolutely key to managing the complexity.
It really does. Without that, building something like this would be exponentially harder.
So this deep dive showed us a blueprint for a web scraping workflow builder, a powerful tool.
But the underlying architecture, this idea of visually defining steps, connecting them, planning execution, managing state, it feels much broader than just scraping, doesn't it?
Yeah, definitely.
Which brings us to a final thought for you, the listener. We've seen how this node-based modular execution works for web automation, but where else could you apply this pattern? Think about other complex multi-step processes, maybe data processing pipelines, orchestrating sequences of API calls for integrations, even modeling certain kinds of business processes.
Yeah, anywhere you have discrete steps with dependency.
Exactly. Once you have this kind of foundational engine for defining, saving, executing, and monitoring modular tasks visually, what else could you build with it? The potential seems pretty vast. Something to think about.